Today we are going to start a new chapter, that is alternating current. All of you know that there are two types of electricity, that is AC and DC. And we know that AC is produced by a generator and DC is produced in a battery or a cell. And all of you know the difference between AC and DC and how the generator works and how it is producing alternating current. There are a lot of differences between these two currents, that is AC and DC. In this chapter, we'll discuss in detail about the different effects of AC when it flows through the different components like inductor, capacitor, resistor, etc. in a circuit. Okay? Listen all of you. Today we are going to explain a very interesting lesson that is about alternating current. An alternating current means the electric current whose magnitude changes with the time and direction reverses periodically is known as alternating current. So this is the definition of alternating current. The electric current whose magnitude changes with the time and direction reverses periodically is known as alternating current. You can see in this graph, the magnitude of this current is keep on increasing and then decreasing, then changing the direction to opposite side. Okay, so this way, if the magnitude as well as direction changes continuously, that type of current is called alternating current. Okay, now here we can represent an alternating current either by using the equation I is equal to Im into sine omega t, Im into sine omega t, or it can be represented by using the equation I equal to Im into cos omega t. But in our textbook, we are using I equal to Im into sine omega t in terms of sine function. Okay. The same way, the voltage in the circuit also can be represented as V equal to Vm into sine omega t. Voltage is equal to V is equal to Vm into sine omega t. V equal to Vm into sine omega t. Now, to understand this lesson thoroughly, we should have a clear idea about these two equations, the equation of current and voltage. Okay. In this equation, the first equation, the equation number 1, this equation number 2. The first equation represents the instantaneous value of current flowing through a circuit. Here I represents the instantaneous value of alternating current which is flowing through a circuit, and this Im is the peak value, maximum value of alternating current, and this sine omega t represents the variation. Here omega t is the phase of the current. It is called phase of the current. This omega t is equal to theta. Actually omega t is the angle theta. Now we can see how this equation we can obtain from the working of a generator. See here, we have a generator. There are two magnets, north pole and south pole, and a coil, armature coil is rotating in between that. Okay, we can take the different stages of rotation. Initially, suppose the armature is like this. Okay, that time, if you draw a normal to the plane of this coil, that is this way, and direction of magnetic field also same. So in this equation, this omega t or theta, it is the angle between direction of magnetic field and normal drawn to the plane of the coil. Normal drawn to the plane of the coil. If I am drawing a normal to the plane of the coil like this, perpendicular to the plane of the coil, this way. Okay, and here it is 90 degree when it is rotating this way. Here it is opposite this way, the normal, and here it is upward. Okay, and here it is again in the direction of magnetic field. So these are the normal to the plane of the coil. Now you see the first diagram, initial stage of rotation of the armature. So at that time, the magnetic field is always from north to south, and normal to the plane of the coil also same direction. So we can take omega t equal to 0. Omega t here is 0. Omega t, that is theta. Theta or omega t is equal to 0. When you apply this value, omega t 0 in the first equation of current I, or in the second equation of voltage V, if you apply omega t equal to 0, sine 0 is 0. Therefore, current I equal to 0. that you can see on this graph. In this graph, we have taken omega t or theta on the x-axis and the voltage induced in the y-axis. Voltage induced in the y-axis. In the equation of the voltage, V equal to Vm into sin omega t. If I substitute omega t equal to 0, that theta equal to 0 here, then sin 0 is 0, then V equal to 0. Vm into 0 will be 0, means voltage will be here. At the same time, if I apply omega t 0 in the equation of current also, sin omega t, sin 0, 0. So Im into 0 is 0, current equal to 0. Means current also will be at that time at this point. So if I take voltage or current on y-axis and omega t or theta on x-axis, okay, and the armature started rotation in this direction. Okay, suppose it started rotation in this direction. When it rotates 90 degree, from initial position, you can see now the normal is downward, magnetic field is this way, angle omega t is equal to 90 degree, theta equal to 90 degree. So in the equation of voltage, if I apply omega t equal to 90 degree, sin 90 is 1, then V equal to Vm. That time the voltage become maximum. So we can see here in this graph, gradually the voltage increases from 0 to a maximum. So this is the maximum value of voltage. This value corresponds to, on y-axis, this corresponds to the peak value of voltage Vm. So voltage reaches maximum when the armature rotates 90 degree, from 0 to 90 degree. Okay. At the same time, in the equation of current also, if I apply omega t equal to 90 degree, sin 90 equal to 1, I equal to Im. Current also gradually reaches to maximum. So the current, if I am drawing here, from 0, it will reach to maximum. So at this point, voltage is maximum and current also is maximum. Now again, if the armature is rotating from this point, once again 90 degree. So total from initial point, initial position, total will be 180 degree. Now this is the direction of the normal to the plane of the coil, and magnetic field is this way. Between these two directions, magnetic field and normal to the plane, angle is 180 degree, 180 degree. Then if I substitute omega t equal to 180 in equation number 2, V equal to Vm into sin omega t. If omega t is 180, sin 180 is 0, sin 180 is 0. So V become again 0. Sin 180 equal to 0. So Vm into 0 equal to 0. Voltage equal to 0. Means from voltage from the peak value again decreases to 0 when the armature rotates total 180 degree. Okay, that is the first half of rotation. The same time, if I apply the value of omega t 180 degree in equation 1, current also becomes 0. So we can draw the current gradually from peak value of current, it will come back to 0. Okay, this value of current is Im, peak value of current Im. Okay, and here this is peak value of voltage. Okay, now next quarter rotation from this point, again if it rotates this way, that is from initial point position till here will be 270 degree, and that time again in the equation 2, if I apply omega t equal to 270 degree, sin 270 is minus 1, so V is equal to minus Vm. V is equal to minus Vm. That time we can see the graph will go to opposite direction. The voltage will increase gradually in the reverse direction and become negative peak value. That is, at this point, the voltage value is minus Vm. Voltage reaches negative maximum. At the same time, in the equation of current also, if I substitute omega t equal to 270 degree, is 270 degree, sin 270 is minus 1, I become Im. Means current also increases in the reverse direction, opposite direction, and become maximum at 270 degree. So this is minus Im. This value is negative value minus Im. Okay. Now in the last quarter rotation, that is 360 degree. Again, if it rotates this direction, so it completed one full rotation, that is 360 degree. When we substitute here omega t equal to 360 degree, omega t equal to 360 degree, sin 360 is 0. So V equal to Vm into 0, voltage becomes 0. At the same time, current also omega t equal to 360 degree, I is equal to Im into 0, then current becomes 0. So both the current and voltage reaches 0 at 360 degree rotation. That is, voltage reaches from negative maximum to 0. At the same time, current also decreases to 0. This is called one cycle of AC. This is called one cycle of AC. In this case, the first half rotation of the armature coil, this much part of the graph is formed. Okay, this is the positive half cycle of the AC, and an equal negative half cycle is formed during the next half rotation. Okay, so here you can see on this graph from the equation 1 and 2, if you apply the value of omega t, at different point here on the x-axis, when you give different omega t value or theta value, you will get different current value and voltage value. So every instant of time, the magnitude of voltage and current are changing. It is keep on changing, increasing to maximum, again decreasing. After 180 degree, it is reversing the direction, changing the direction, and going in the opposite direction. Again, next rotation, it will start in the positive direction. This way, the electric current, whose magnitude changes with the time. Every instant of time, the magnitude is changing. You can see every instant of time, the magnitude is changing. So the electric current, whose magnitude changes with the time, and direction reverses periodically. Direction reverses periodically means in each half rotation, in each half time period of rotation, the direction will reverse. And such a current is called alternating current. Okay. So from this equation, it should be very clear. This value I represents the magnitude of current at different instant of time. On this graph, Im is the peak value, maximum possible value of current, and sin omega t represents, omega t is called phase of the current, and sin omega t shows the variation of current, increasing and decreasing of current. The same way in voltage also, V is the instantaneous value. At each instant of time, the voltages keep on changing. Vm is the peak value, the maximum possible value, and sin omega t represents the variation, the sine wave formation of the voltage, and omega t is the phase of the voltage. Omega t represents the phase of the voltage because omega t value tells us where is the voltage right now, whether voltage is at 0 or it is at maximum or it is negative maximum. This position of voltage and current we can obtain from the sin omega t value. So this represents the phase, the position of the voltage or current at an instant of time. Okay, so this equation, once again, I is the instantaneous value of current, Im is the peak value, maximum value of current. In sin omega t is the phase of the wave. In that, omega is the angular velocity of the armature. When this armature rotates, omega represents its angular velocity. For a given generator, omega will be constant, but time is variable. Then omega into t, theta is equal to omega into t will be variable. It will be keep on changing. Okay, and this value of Vm and Im, that is peak value of voltage and current, that depends on a generator. For a generator, this Vm and Im will be constant. For a given generator, value of Vm and Im depends upon the number of turns in this armature, number of turns in the armature coil, and also this area of the coil, and the angular velocity, and the angular velocity of the rotation of the coil, and also the material of the core used here. If the soft iron core is used here, then the value of Vm will be maximum. So it depends upon Vm and Im depends upon the number of turns of the coil, the area of the coil, the material of the core used here, and the angular velocity, the rotation angular velocity omega of the coil. Okay, but V and I are keep on changing every instant of time. So this is what is the basic idea about alternating current and alternating voltage. Now, the main problem we are facing in an alternating circuit is that we don't have a fixed value of current and voltage. So when we want to calculate some value of resistance or potential difference across a device in a circuit, we have some difficulty here because voltage and current are keep on changing. So what we can do here, when we try to take the average value or mean value of voltage and current in one full cycle, what happens here, in the positive half cycle, we can see the maximum voltage is Vm. So if I take average value of voltage, V average, or mean value of voltage, that is maximum is positive half cycle, it is Vm, plus in negative half cycle it is minus Vm. Negative half cycle, the peak value of voltage is minus Vm, positive is plus Vm, negative half cycle is minus Vm. Then if I take average in the full cycle, I should write plus Vm minus Vm divided by 2. This will be equal to 0. Same is the case of current also. If I am taking the average value of current, I average, if I am taking I average, IAV, that will be equal to, in the positive half, we have plus Im maximum, negative half minus Im. Then if I take the average value, I should write positive half plus Im plus negative half minus Im divided by 2. This also will be equal to 0. So when we take average value or mean value of voltage and current in full cycle, that will be equal to 0. So we cannot take this average value of voltage and current in AC circuit. So what we do normally, when we take the average value of voltage and current, we will not take the full cycle. We will not take the full cycle. We will take only one half cycle. Only one half cycle. If you take only one half cycle, we can prove that in one half cycle, average value of voltage V average will be equal to 2 into Vm by pi. 2 into Vm by pi. We can prove that the average value of voltage in one half cycle will be 2 Vm by pi. The same way, the average value of current also. I average in a half cycle. Will be 2 Im by pi. 2 into peak value of current divided by pi. Okay. So when we take average value or mean value of voltage and current, we will not take full cycle. We will take only one half cycle. In one half cycle, mathematically we can prove that average value of voltage will be 2 into peak value, maximum value of voltage divided by pi, and average value of current also in one half cycle will be 2 into peak value of current by pi. Okay. But more than this average value, we depend on RMS value of voltage and current, not the average value or mean value. We depends on RMS value of current and voltage, IRMS and VRMS. And what is actually RMS value of current and voltage, that I will explain in detail in next video. Okay, thank you.